Hello everyone, my name is Luis Valencia and today we are going to talk about Azure Cognitive Search. I'm a Microsoft MVP, my Twitter handle you can see it on the screen and my website as well. I'm a solutions architect at PricewaterhouseCoopers in Belgium. I've been MVP for 4 years. I have 18 years of experience as a software developer in many different technologies and language. But the last years I've been focused on SharePoint Office 365 and recently in different Azure services as well. Like today we are going to see Azure Search or Azure Cognitive Search because it was renamed recently. I'm the founder of a new group. You can find it on Facebook. It's called Brussels Developer User Group. We have a meetup group in meetup.com. We have our first event on February 4, 2020. And we are going to have two sessions that day. One about cognitive search, and the second one about Kubernetes. So feel free to reach out to those websites if you want to register and join for the talk. Now, let's talk about Azure Search or Cognitive Search. So what is it? It's a search as a service or software as a service cloud solution to provide developers an API to search on any type of content. The type of content can be indexed automatically by Azure Search if it's in Azure, like Cosmos DB, SQL, blob storage, for example, or can be pushed. There is an API to push data from different data sources. It can be Google, SharePoint, or whatever you want. What are the benefits? So, as I said before, we can index multiple content types from different platforms. It has artificial intelligence features, and that's why Microsoft renamed it because in the past, 2 months ago, it was called Azure Search, but it was renamed to Cognitive Search because it's integrated deeply with the cognitive services in Azure. That's why it allows to extract data from image from PDF files. It allows to extract entities from raw text as well. It allows also to create intuitive search experience with facing navigation, filters, synonymous, autocomplete, etc. We will see that in the demos. And it allows to create a specific use case scenarios like geo search. With Azure Search, we can integrate with Bing services, with Bing geolocation services to integrate the Find Near Me experience. What are the core search features? So first one, talking about free from text search, we have different scenarios and this full text search where you only type some keywords and you get the results. Simple query syntax, where you can actually start playing with logical operators like and, or, parentheses, things like that, suffix. And there is also Lucene query syntax, where you can use some advanced syntax to use fuzzy search, proximity search, term boosting, and regular expressions. Another core search feature is simple scoring. So every time you type and you make a query against the index, you will get a score for the results. A score is a number between 0 and 1, or a percentage, if you want to say it that way, that will tell you the score of the results. The higher, the better. And we also have a GeoSearch, as mentioned before. Other features, filters and facets. I think filters is very clear for us. Well, let's talk first about facets. So facets with a simple search parameter in the API or a simple method in the SDK, you can tell the index to return the filters based on your query terms. So if the index, let's suppose you are indexing content for a store where you are selling clothes, then every cloth you will have metadata. So if the cloth is for male or female, the size, the color, those are categories, right? Those are categories that you can use filter on. Basically, in any shop like Amazon, Newegg, whatever, you will see the filters on the left, right? But with facet navigation, what you do is you tell the search engine to return the filters automatically. So the front-end developer, they don't have to hard code the filters on any language that you're developing the front end. The filters, the categories of the results will come automatically from the results. Other user experience features are autocomplete and search suggestions, just like Google, like Bing does. Synonyms, hit highlighting. Hit highlighting is when you search, it will allow you to highlight your terms in the results, and sorting on paging, which is self-explanatory. Talking about artificial intelligence features, so we have cognitive search, which allows to extract information from image or from PDFs using built-in skills like character recognition or using custom code skills that you can attach to the pipeline. So in cognitive search, you have a concept called a skill set. A skill set is a set of skills, obviously, and that set of skills can be customized with your own code. So if whatever Azure provides is not enough, like recognizing people, recognizing landmarks, recognizing countries, for example, then you can customize it as you wish. And there is a new feature which is in preview is the knowledge store. It's an extension of artificial intelligence based indexing where the data is stored in Azure blob storage, and it's basically storage with the enrichments you do during indexing and during the pipeline, right? Then you can use that storage to improve your skill sets afterwards using machine learning, for example. Yeah. Talking about data importing and indexing. So automatically there are indexers for SQL database, for Cosmos DB, for blob storage, for example. But you can use a push API. What is the push API? Basically, if your data source is not in this list, is not supported, like Google Drive, then you can create a custom code to push content into the index. For example, if you have a Google Drive, a Team Drive, a Dropbox, and they have an API to go through those documents, get the metadata of those documents, and get the text of those documents, then you can push it to the cognitive search index. Then, from a simple screen, from a simple portal, you can search across all your data sources. The data in cognitive search is stored as JSON. So basically, you can use any complex type. You are not tied to a simple tabular data. You can use any custom JSON object in the index itself. And as I said before, linguist analysis, we have Lucene syntax to search for the index, but you can also have custom lexical analyzers. Yeah. So Microsoft has provided us some out of the box analyzers for the search, and they work pretty well. But you can customize it. You can add it to use your own analyzers during the linguistic analysis phase. Start with the demo, provision an Azure search engine, search service. That's very easy. So you simply, I'm combining English with the Spanish, Azure Cognitive Search because they changed the name. Okay, let's find it. Cognitive services, cognitive search. You have it here. Yeah. So basically, you select a resource group, you give it a name, you select a region, and then you select a pricing tier. For demo purposes, I created the instance of the service beforehand. There is a free tier, but you can only create one free tier on your subscription. After you create the free tier, then you have to use the standard or basic or these other ones. You can see in the documentation the difference about this. Okay, let's go. So that's the very first demo, no big deal. Then let's talk about indexing our first set of data. So let's go to our search services, and you have the button here, import data. You click on import data, then you select what data source. It can be SQL database, SQL Server on an Azure VM, Cosmos DB, blob storage, or table storage, right? So for this example, I'm going to use Cosmos DB, but basically because I'm using the free instance, I cannot create more than 3 instances, right? So my Azure search has a limit of 3, and because I already have 3 indexes, I cannot use the import wizard anymore. Anyway, it's very simple to use. You select the data source, you put a name, you select the connection to that string, to that data source. In this case, it's Cosmos DB. Then you also use the database, the collection, and then a query. If you don't put a query, then it will index everything by default. Okay, let's go back. Let's talk about the architecture. So whenever you make a query, there will be a query parser. So the query parser will get from your query terms, will create a query tree, let's say. That query tree will be sent to the analyzer. There are multiple analyzers provided by Microsoft within the product, within the service. Once the analyzer is done, it will return the analyzed terms, and it will make the query against the search index, and then you will get the results. And that's basically what I had in this slide, right? Let's talk about more demos. This I already explained it basically on the few minutes before. Basic search. So I have Visual Studio in here. I'm going to run this demo and I'm going to show some of the code. So here we have in the app settings, we have the search service name and the service query API key. So this is a sample provided by Microsoft itself, where we can play with the data. We can make queries against this index. It's about hotels, so you can find hotels here. Yep. We can search for it. It's really simple. Now let's check out the code. We go to the home controller, and then you have the init search method. The init search method will read the settings from the app settings.json. It will get the search service name, the query API. It will create a service client object and an index object. Remember that every search you do has to be against one index, right? So we are using the index called hotels, and then we run a query, and the query is really simple. So with the index client object, we tell Azure to make a query asynchronous with the search text and the parameters. The parameters is, in this case, what information must be returned in the results, right? The search parameters object is the one of the most important ones, and as you are going to see in the next demos, we will use it extensively to customize the experience, the search results that we are going to get. Paging, sorting will be done always through the search parameters, right? And that's basically it for the basic demo, right? Then we have paging. Okay, back to sorting. So in the sorting demo, we have the controller action here, the index, and basically what we do here, so I'm going to omit this part, is to define how do we want to sort. We can sort by a field from the index, so in this case by rating or by last renovation date. So we can see it in the demo. So in the user interface, we can see that we customize the order results. So we can use the default ordering, or we can use the rating by amenities or by renovated date. So as you can see here, we have other fields in the results. One is the rating, one is the last renovated date, and the rates, right? So if we go back to the code, there is a switch here. If we are using the rating renovation, is only a matter of adding a simple expression to the order by list of strings, and then we will send it. How do we send it? Is with the search parameters again. Again, this object appears here where we can use an order by expression, or we can use an scoring profile. So by default, cognitive search will return the results in the default scoring, let's say it that way, but you can customize the scoring. How? So basically, you create a profile, which is just a string, and then with this logic here, you add or you change the scoring of the search results based on amenities, right? So if we search by amenities, then the result will come in a different way based on this. As you can see, it has air conditioning, bar, continental breakfast. This one has view, pool, whatever. And there is a custom logic here of the amenities, and there is a custom logic here for scoring those amenities, right? Based on the counting, let's say it that way, right? And that's it for this demo. You can see the line to search is exactly the same. The only thing that changed is actually the search parameter subject. Yeah. And let's go back to the next demo, and that's infinite scroll. So I have to stop Visual Studio again and open the infinite scroll demo. Everybody knows what infinite scroll is. You can see it in Instagram, in Facebook, Twitter, and you can use it very easily in cognitive search. So we search, it will get some results, by default is 4, but when you get to the bottom of the results, it will render more and more and more. Okay, how do we do that? So let's go to the code. So first there needs to be some logic on the user interface. Here is with jQuery, and basically is we have a scroll function, and when it gets to the bottom of the screen, what we do is we call a controller on the backend, and then in the controller in the next here, then we do the same search basically, right? And we return the results as JSON. Where do we do the search? You can see here await index. So when you get when you make the first query, you will search with the same type of code that I showed in the previous demo. So this will return the first 4 results, I think, with the same line of code that I showed you before. But when the user scrolls down, then we will call from jQuery the next method, but inside the next we have a call to the index. And as you can see in the model, there is a parameter paging, and that will tell you to get the next page of results. It's not a page, it's just another set of data within the same page, but I'm pretty sure you understand what I mean, right? And that's basically it. Really, really simple. You can use Angular, React, whatever to do the infinite scroll, right? Next, type ahead. That's really, really nice demo. And that's type ahead. Let's see it here. So, type ahead, you already know it, in Google, in Bing, in any search engine, even in Amazon, Newegg. You start typing and it will give you some suggestions. In this case, it will return the first 3 hotels with the suggestions. But before that, I have to clarify something. Type ahead and suggestion is 2 different things, right? Type ahead is when I put when I type 2 letters you see it automatically puts a spa, right? That's type ahead, and this enriched by the index. So based on the data on the index, it will return that suggestion to finish search with spa. And the second is suggestions. So suggestions are done on the bottom based on whatever you want to type, right? Restaurant. You see, you get the suggestion about one. Let's search for resorts. Those are the suggestions for resort. How do we do it in the code? So basically, we have an autocomplete method, which will get the top 6. As you can see here, in this case, we are not using the same search method, but we are using the autocomplete async. And this method is based on the same index client. Yeah. There is another method with called autocomplete and suggest, and that's for auto-completing the first word that when I was typing SP, for example. So first we autocomplete, and then we call the suggest async based on whatever I type it on it. Okay, and then we just run the query after you type, and this is the same search async. So I have to be clear here. One thing is type ahead, which is autocomplete. So I type SP and Azure Cognitive Search will return SPA as the term I want to search, just like Google does. Then suggest. So based on SPA, on the drop down, it will return the top 6 authors which match the term spa. But when you hit enter on your keyboard, then it's where it will actually make a query against the index. So that's basically it. Facet navigation or facet navigation. So let's close this demo. And I have the Facet navigation menu solution here. So I start running it, and while it runs, I will show you the code. So we have a, let's see. So, okay. So by default, it will go to the index method. Here we will run the query by default. Let's say it. And on the results, you will see also filters. Those filters are automatically returned by Azure Cognitive Search. But how do we do it? So we didn't have to develop the front-end HTML for this. How do we do it? So basically, the first time the face filter will be empty, right? So it will use this facet filter, which basically mean it's an empty filter. Okay, it will only search for the text that you typed, which is spa, but the filter is empty. But it will return the facets you mention in this parameter category and tags with a maximum count of 20, correct? And you see categories and tags are just amenities, okay? However, the second time you search but filtering down the results as you do on Amazon, for example, resort and spa 12, for example, at that time, the filter expression will be built using this line of code, and then it will be sent to the query to get those data. Okay, you can see that in the query string we put the search expression as well, and that's basically it. Now we already did that. Now let's talk about cognitive search. So as I mentioned at the beginning of this video, uh, Azure Search was renamed to Cognitive Search because it used Cognitive Service API to enrich the index uh, with computer vision and text analysis. However, you can customize it with custom skills. So what's the process? You get the data from a data source, let's suppose blob storage. So here I have a blob storage container with some pictures. One of them is Satya Nadella. One of them is Scott Guthrie, for example, in his red shirt. Then you apply document cracking. That's done by cognitive search. You only need to define where to get the data from. And the second step is that it actually is actually the enriching phase. So it takes that data and it applies the cognitive skills. So it will try to find if the people in the picture is recognized, if it's a famous, if it's a celebrity, then it will enrich the index with data from the celebrity, like the name, for example. But it's not only for people, it's for other things in the picture itself. If you have skyscrapers, if you have a picture of Manhattan, then it will recognize buildings, skyscraper, blue sky, things like that. Okay. Once you have that enrichment, then that data will be pushed to the index. Yeah. And the index can be used with the same code that you saw in the previous step, right? The demo is really simple and there is no user interface for the demo. What I want to show you here is I have the cognitive search and I have a search explorer here and I have an index that is connected to my blob storage. As you can see, I have some pictures and I also have PDF documents PPTX. One of the picture is Satya Nadella and the Linux logo in a picture. And here, then I can return results based on the enrichment. Linux is a key term that is not text, is a logo on the picture, but in the enriching phase, using the computer vision API, cognitive search will automatically enrich the metadata of the index with that data. Yeah, and even you can see even the pixels or the bounding box where they found the Microsoft and Linux text on a field. As you can see, it will also recognize person, human face, man, clothing, glasses, because in that picture, Satya Nadella has some, is wearing glasses as always. Let me see if I can open it. I don't want to wait too long. Okay. Let's search for something else. Building. Yeah. As you can see, there is another item in the index where it recognized that there was a sky, cloud, building, architecture, water, etc. Right? We can also, okay, you see the picture, Microsoft, Linux, it doesn't recognize the heart, but it recognizes that there is a man wearing glasses, right? We can also recognize or extract celebrities. Scott, I think is with double T. Yep. You see, there is a metadata field called image celebrities, and it was recognized Scott Guthrie was in that picture. And I think it's this one. In the meantime, I will close this, and you see. So as you can see, there is no text in this picture with the name Scott Guthrie. It's only the image and it's recognized automatically by cognitive search. Okay. Something I forgot to mention is the search score. In any results, you will always have a search score, and that's basically the percentage that the algorithm thinks that results matches the key term used by you, right? And let's go back to the slides. And that's it for today. Yeah, that's this is the wrap up. This is a very basic video explaining the basic functionalities. You can also use the push API to customize it, maybe using an Azure web job connected to Google Drive to index Google Documents or Dropbox. You can use Azure Functions to push data from another data source like, I don't know, ServiceNow, Zendesk, Jira, whatever you want to index, right? I hope you like this video informative. I hope you learned something for it. Don't forget to check the samples in the URL mentioned in the slide. You can check my blog on the screen and my Twitter handle. And please follow me on the meetup.com Brussels Developer User Group. See you in the next video. Thank you.